Welcome back, guys. Today we are going to continue on our exponents and logarithms unit. And in this lesson, we're going to be looking at 6.7, evaluating logarithms. In our last lesson, we looked at how to convert from exponential to logarithmic form. We're going to continue that on so that we can actually look at a logarithm and evaluate its value or determine its value. All right, so let's take a look at an example here. A student was asked to evaluate log base 2 of 8. We're going to take a look at the steps here and use these to determine what was done in order to determine the value of the logarithm. So if we look at our first step here, we have log base 2 of 8 equals v. So essentially what the student has done is they've rewritten the logarithm and they've set it equal to v. So they've said, let's let log base 2 of 8 equal v. In the next step, they've rewritten the expression in exponential form. So this is what we did in our last lesson, converting from exponents to logarithms. At this point, they took the 8 and they rewrote it as base 2. So we've written both sides of the equation using base 2. Now, if our powers are equal and our bases are the same, then we know our exponents are the same. So we can equate our exponents. And the last step is just to write our expression. So we replace the v with our original logarithm, and we can write that log base 2 of 8 is equal to 3. So let's take a look at some examples that we can follow through with. All right, so the first example here, we have log base 3 of 81. So using these steps as our guideline, the first thing we're going to do is let our logarithm equal v, so equal the value. We're going to rewrite as an exponent, so 3 to the v equals 81. And then we're going to write 81 as base 3. So 3 to the v equals 3 to the 4. And since our powers are equal and our bases are the same, we can say that v equals 4. So then we can write our logarithmic expression. So log base 3 of 81 equals 4. All right, next question here, we've got log base 4 of 64. Again, we're going to set it equal to v and rewrite as an exponent. So 4 to the v equals 64. And 64 written as base 4 is 4 cubed. So from there we can say that v equals 3 and rewrite our expression as log base 4 of 64 equals 3. All right, taking a look at our next example here, we've got log base 7 of 7 equals blank. Now C, and what we're going to see here shortly with D, C and D are actually properties or relate to properties that we're going to be using quite frequently for the remainder of this unit. So let's take a look at this. We've got log base 7 of 7 equals V. Rewriting as an exponent, we've got 7 to the V equals 7. Well, 7 written as base 7 is 7 to the 1. So v equals 1. So log base 7 of 7 equals 1. Now if we take a look right below there, we've got, I'm actually going to kind of jump around a little bit here. We've got example number 2b. We've got log base b of b equals blank. Well, if we write that, that becomes b to the v equals b to the 1. So v equals 1. So in other words, when our argument and our base are the same, the value of the logarithm is 1. Taking a look at our next example here, we have log base 12 of 1. And so rewriting that, we have 12 to the v equals 1. Well, writing 1 as base 12 means that we have to write that as 12 to the 0 because any base to the power of 0 is 1. So v equals 0. So logarithm or log base 12 of 1 is 0. So taking a look at that identity right here, we have, looking at that identity right here, we have log base b of 1 equals blank. So we're going to replace that with a v. We've got b to the v equals 1. Again, we can write that as b to the v equals b to the 0. So v equals 0. So log base b with an argument of 1 is v. So these are actually two general rules that we use quite frequently, and they state that the logarithm of a number, or another way to say that is argument, so the logarithm of the argument to the same base. So if our argument and our base are the same, we have a value of 1. So if log base b of b equals 1. Now, the logarithm of an argument 1 to any base is equal to 0. So the log of any base with an argument of 1 is equal to 0. So these are common statements for us to know and remember. They're not on your formula sheet, but they're ones that we use quite frequently. All right, continuing on here, we have example number 3. We've got 2 log base 8 of 512. We're going to follow that same process. Let our logarithm equal v. And before we can start writing an exponential form, we're going to have to get rid of the 2. So we're going to have to do a little algebra. Log base 8 of 512 equals v over 2. Rewriting an exponential form, we have 8 to the v over 2 equals 512. 512 written as base 8 is 8 cubed. So we can equate our exponents here, and we have v over 2 equals 3, meaning that v equals 6. So we can say that 2 times log base 8 of 512 is 6. All right, moving right along here, we have log base 2 of 1 over 32. So we don't have any coefficient in front to divide by. We can go straight to writing an exponential form. So 2 to the v equals 1 over 32. 1 over 32 is the same as 2 to the negative 5. And that means that v equals negative 5. And our last example here, we have 5 to the v equals root 125, which can also be written as 125 to the 1/2. But we need to write everything in base 5. So 125 is 5 cubed. Put to the exponent 1/2. So 5v equals 5 to the 3 over 2. So v is 3 over 2. And again, if you're having some trouble with remembering how to convert radicals to exponents, or how to multiply your exponents or use your exponent laws, just go back and review the lesson that we did on exponent laws. All right, last set of examples here. We're being asked to evaluate log base 1/3 of 27. So 1/3 to the v equals 27. We're going to have to write both sides in base 3. So 1/3 is base 3 is 3 to the negative 1 to the exponent v, and 27 is 3 cubed. So we have 3 to the negative v equals 3. So if negative v equals 3, then we know that v equals negative 3. Next example, we've got 4 to the exponent log base 4 of 16. Now this one looks a little bit more complex than it is. We have it in exponential form, so our first step is to write this in logarithmic form. So log base 4 of v equals log base 4 of 16. Now, because we have the logarithms equaling each other, we have the same bases, then we know that these arguments have to be the same. Now, this only works because they have the same base. So we can say that v equals 16. Now, another way to evaluate this question would be to take our logarithm or log base 4 of 16 and evaluate that. So if we have log base 4 of 16, set it equal to v, 4 to the v equals 16. So that would mean that 4 to the v equals 4 squared. So we know v equals 2. And then we could take and plug that back into here. And so that would give us 4 to the 2 equals v. So in other words, v equals 16. All right, one last example on this part. We've got log base 1/2 of 1/8 minus log base 1/2 of 8. Now, up to this point, all that we can do is solve or evaluate by writing in exponential form. There will come a lesson in the next few days here where we're going to look at the laws of logarithms, where we'll have ways that we can simplify this a little bit before we actually have to evaluate. But up to this point, or at this point, all that we can do is evaluate individually. So we're going to take the log base 1/2 of 1/8, set it equal to, we'll call it v1. Rewrite that as an exponent. So 1/2 to the v1 equals 1 over 8. If you just want to write it as v, that's fine. 1/2 we can write as 2, so 2 to the negative v1, and 8 can be written as 2 to the negative 3. So that tells us that v equals 3. Evaluating for our second part, we're going to have to write log base 1/2 of 8. So log base 1/2 of 8 equals v. 1/2 to the v equals 8. So that becomes 2 to the negative v equals 2 cubed. So we have v equaling negative 3. And so that was v2 if you want to label that throughout. So now we're going to take those two values and we're going to plug them back into our original equation. So this one here was valued at 3, and this one here was at negative 3, and we have a subtraction sign in between. So 3 minus negative 3 equals 6. So that entire expression is equivalent to 6. Now, in previous lessons, we've talked a lot about common logarithms and natural logarithms, and these can be used on our calculator. Remember that a common logarithm is base 10, and we can use that log key on our calculator. So log base 10 of 1,000 is the same as log 1,000. And natural logarithms are our ln button. And so this is where we have our log base e being equivalent to ln or ln. All right, so let's just do some practice with the calculator. We haven't done a lot with the calculator yet. On your calculator, if we want to type in log of 1,000, we just type log and then 1,000. Now our calculator knows that when we type log of 1,000, we actually mean log base 10. So log of 1,000 on our calculator is equal to 3. Now, if I wanted to evaluate that using exponential form, I would have to actually put my base in there. So log base 10 of 1,000 equals v. 10 to the v equals 1,000. 1,000 is 10 cubed. So we have v equals 3. So again, we can evaluate both algebraically and with our calculator. We can do the same with ln. So on our calculator, we can have ln of 5. So ln of 5 is 1.6. Log e of 5. Now log e of 5, if you remember from our previous page there, log e is the same as, or log base e is the same as ln. So we can actually type this as ln 5 in our calculator. So ln of 5 is also 1.6. And the last one here, we have ln of e. So if we want to put ln of e in our calculator, we can go ln of e, and we have to put that exponent 1 in there because this is treated like a function. So ln of e to the exponent 1 would give us 1. Now, this again is a property that you could remember. Remember that ln e is the same as log base e of e, and when our base and our argument are the same, we get 1. All right, so let's take a look at evaluating logarithms by changing the base if we can't rewrite using a common base. So here's an example. We've got log base 5 of 50. If I want to evaluate log base 5 of 50, I can start by doing what we've already done. Set it equal to v, write 5 to the v equals 50. But the problem that I have here is that I can't write 50 as base 5. And that's a problem because I can't then get my exact answer. So let's think about what log base 5 of 50 could be. So if we think about our exponents, our base 5s, we have 5 to the 1 is 5, 5 to the 2 is 25, 5 cubed is 125. Well, if we look at just those values there, we know that 50 falls somewhere between 25 and 125. And so we know that our logarithm, or the value of our logarithm, has to be somewhere between 2 and 3, and probably closer to 3. So maybe like 2.6 or 2.7. So we know that it's somewhere between there, but we can't get an exact value by writing as a common base. So since we can't do it that way, we have to go to our calculator. So we can evaluate the logarithm using a calculator by changing the base of the logarithm to a base that the calculator recognizes. And we're going to use that by using the common logarithm or the natural logarithm. So our identity, and this is on your formula sheet, is log base b of c is log of c divided by log of b or ln c divided by ln b. Now let's take a look at an example of that using an investigation example here. So we're asked to evaluate log base 5 of 25 by converting to exponential form. So using what we had before, we'd have log base 5 of 25 equals v. So 5 to the v equals 25. 25 is 5 squared. So we have v equals 2. Now if we go on to our calculator, we can type in log of 25 divided by log of 5, and we also get 2. We can also type in ln of 25 divided by ln of 5 and get the same answer. Again, it doesn't matter whether we're using the log or the ln because we still have the same base in our numerator and our denominator. So we still get 2. And so what you should be noticing is that they are the same. Now let's try this with one more example. We've got log base 3 of 243. If we want to convert this to an exponential form, we can write that as log base 3 of 243 equals v. So 3 to the v equals 243, and 243 written exponential form is 3 to the 5. So we've got 3 to the v equals 3 to the 5. So v equals 5. Now again, checking out our calculator, we can go log of 243 divided by log of 3, or we can go ln of 243 or log e of 243 over log base e of 3. So ln of 243 divided by ln of 3. And again, we get the same answer. Now, your formula sheet actually has this formula on it. And so it says that log base b of c is log base a of c divided by log base a of b. In other words, it doesn't matter what our base is as long as it's the same in the numerator and the denominator. So we can have log base b of c equals log of c divided by log of a, and you can plug in any base you want. We can have base 10, base 2, and so on. It's not going to matter. Now with our older calculators, the TI-83 pluses, this is the only way that we can evaluate a logarithm on our calculator. If, however, you have a newer calculator, you can also enter it in another way. Your calculator actually has that log base mode. So for the TI-84 pluses, another way to enter in your logarithms is to push the math button. And then I usually arrow up to the top of my, or push the arrow up because it'll actually take me to the bottom of my list. And I want A. So I want A, and it's going to say log base with a bracket. And when you hit enter, you're going to get something that looks like this. You're going to have log, little box, and then brackets and a big box. And so this is where you'll enter your log base. So if I wanted to enter, for example, log base 4 of 1024, I would actually arrow down, put my 4 here, and put my argument there, 1024, and it would give me my answer. On the older calculators, we have no choice but to write log of 1024 divided by log of 4, and because some calculators have the log base feature and some don't, that's why they're keeping that formula on your formula sheet. All right, so let's evaluate some of these on your calculator. Again, I have an older calculator for demo purposes here, so I'll be entering it in using this method. The newer calculators, go ahead and try it using the math feature. All right, so if I want to figure out log base 4 of 1024, I'm going to go log of 1024 divided by log of 4. And that's going to give me 5. Next question we want to evaluate, we've got 3 times log base 2 of 1 over 1,000. So in order to put that in our calculator, we're going to have 3 times. Now I would put this part in brackets. Log of 1 over 1,000. So log of 1 over 1,000. Be careful of your brackets. Divided by log of 2. And we get negative 29.9. All right, so let's write those in here. So for the first one here, we went log of 1024 divided by log of 4, and we got 5. For this one here, we went 3 times log of 1 over 1,000 divided by log of 2. And we got negative 29.90. As we enter these in our calculator, some just get a little bit more complex. So for the next one here, we have 6 to the exponent log base 6 of 216. Sometimes it's easier to actually just figure out your logarithm first and then put 6 to the exponent of, but we can put it in our calculator in one step as well. Let's try it by putting it in separately first. So we could go log of 216 divided by log of 6, and then we can just go 6 to the exponent 3 gives us 216. If you want to put it in one step, we would go 6 exponent bracket log of 216, close your brackets, divided by log of 6, close your brackets, and you have 216. So we've got 6 to the exponent log of 216 divided by log of 6, and that's going to give us 216. Now for our last example here, we have log base 2 of the square root. So we can go log of root 1 over 1024 divided by log of 2. And putting that on our calculator, we should get negative 5. So let's check it out. So we've got log of root 1 divided by 1024, close your brackets, divided by log of 2. And we get negative 5. All right, let's take one last example, or look at one last example here, and this is where we're going to be graphing with our calculators. Once we know how to put these into our calculator, we can actually use our calculator to solve equations. So consider the function f of x equals log base 7 of x. If we wanted to put this in our calculator, we have to put it in as y equals. With the newer calculators, you can actually write this in as log base 7 of x and graph it just that way. With the older calculators, we have to put it in as log of x over log of 7. Now we'll also set up some window settings here. Our window settings for this will be 0 to 20,000, and we'll go up by 5,000. And our y values will go from 0 to 10, and our scale will be 1. So let's set that up on the calculator here. So graphing, I'm going to have log of x. Again, older calculators, make sure you're very careful about those brackets. Divided by log of 7. And setting our window settings, we're going to go from 0 to 20,000, by a scale of 5,000. And our y scale will go from 0 to 10 and go up by 1. And so looking at our graph, we'll have something like this. Okay, and remember this point here is at 1, 0. All right, so using our calculator then, we can graph the following equation. So if I want to graph log base 7 of x equals 5, well, y1 is going to be the log base 7 of x, and y2 is going to be 5. If I want to graph the next one here, I would have my y2 as 0, and my y1 as 3 log base 7 of x minus 9. So let's take a look at the first equation here. I have log base 7 of x, so entering that in, that's going to be log of x divided by log of 7. And my second equation is 5. Now again, you can use zoom fit as a starting point. So zoom fit is zoom 0, and that will often give you a way to graph both equations where you can see your intersection point. Finding our intersection, we have second calc intersect, enter, enter, enter. And that gives us an intersection point of x equals 16,807. Let's try the second equation here. We've got 3, and entering this part in, we're going to have to go log of x divided by log of 7. And then minus 9, and we're intersecting that with 0. Again, we can use zoom fit. to graph our equation. All right, so second calc intersect. And we have x equaling 343. Now, if you had wanted to rearrange your equation beforehand, you could certainly do that. We could have written this as 9 equals 3 log base 7 of x divided by 3 and have 3 equals log base 7 of x. And then we would have intersected with y2 being 3 and y1 being log base 7 of x. Either way, we're still going to get that answer of 343. All right, now if we were to solve these in exponential form, if I've got log base 7 of x equals 5, if I want to solve this equation, the first thing I'm going to do is rewrite in exponential form. So 7 to the 5th equals x, and if I put 7 to the 5th on my calculator, I'm going to get that x equals 16,807. For the next equation here, if I want to get x by itself, the first thing I'm going to do is bring over the 9. So I'll have 9 equals 3 log base 7 of x. Divide by 3 on both sides, and we're going to have 3 equals log base 7 of x. And then writing as an exponential form, we're going to have 7 cubed equals x, and that means that x equals 343. So as soon as we have an equation, that means there's an equal sign, we can solve both algebraically by writing in exponential form or graphically by putting it on our calculator. All right, guys, so that's a lot of examples for today. Hopefully, you'll have enough practice here to understand the concepts. Make sure you get a little bit of practice, and we'll see you soon.